because that's where I put it, because that was my desk.
That was your desk?
That one was my desk. And so since I changed to this one, I needed
Oops.
I wanted a bigger desk. Because this printer didn't have a place, and I needed a place for that printer. So, yeah. Anyway. Oh crap, well, I'm recording. Alright, class.
Yes.
Thank you. Alright. So, we're going to go over definite integral, Riemann sums. So now, for these ones right here, n, it'll give you the n, so it'll tell you how many parts. But you're also going to have Riemann with non-equal intervals. So you know how my delta x was a certain value before? That was the width of each one of the rectangles from the last unit. Now we're going to change it. Now we're going to give you a table, and it's not all going to be the same parts. So you're going to have to do the math for each rectangle or each trapezoid or each midpoint individually. Does that make sense? So yeah, so that's using it with the table. We're going to talk about definite integrals, and yeah, we got some good stuff. I like this stuff. I like it a lot. So, there we go. Alright, so, forming Riemann sums. For the function x squared minus 3 from 0 to 6, partition from 0 to 6 into 4 subintervals, where, right here, and form Riemann sums for which. So this is the left side or the right side. So now, this one right here, the width is what? The width is? The width is? Width is? That's important because when we try to throw it in a formula, it doesn't work out very well. So we're going to have unequal parts for this. So this is going to be left endpoint. So if I look at a graph, and my number line is going to look like this: 0, 1, 2, 3, 4, 5, 6, and then 1, 2, 3, 4, 5, 6. There we go. All right. So from the left-hand side for each one, for the left-hand side, it's going to be my width. Okay, these are rectangles. So my area 1, okay, my area 1 is going to be my width, which is 1, times the height, which is going to be the left-hand side. So this is my first rectangle right here. That's the base of it. That's going to be the left side, which is going to be a 0, right? Times f of 0. Is that notation okay? Helping you on this? Because we don't have a graph for this. We're just going to have to plug it into this function for this. Plus, my next interval, which my width is from 1 to 2, it's also going to be 1. It's also going to be 1, so that's going to be 1 times f of what? 1, very good. Plus, my next interval, which my width is 2, very good, times, so it's going to be from here to here, from 2 to 4, and times f of 2, plus my last interval, my width is 2, times f of 4. Okay, so let's go through and do the math on this. So f of 0 is going to give me -3. times 1. There we go. F of 2. 1 times 2. 2. Yeah. Next one, f of 4. 4 squared is 16. 16 minus 3 is 13. 13 times 2 is 26. So my total area of this is going to be 23. Okay. Now, that's important. How did I get a negative area? It is under the x-axis. So if I were to graph this now, I'm going to just sketch the graph that I have here. So this one is like -3, -2, and then at, did I have 2? Came out to be 1. So, like this. So, horrible graph. Like that. So, rectangle here. This is 1 right here. And then the rectangle here.
That's not exponential graph.
I know it's not. And then this one. My graph is not very. So I'm trying to show this part right here. Anything that is below the axis, the x-axis, is going to be a negative areas. Anything below is a negative area. Everything above is a positive area. And this is going to come into a concept later on where we're going to actually have to deal with total area. Okay? So we're going to have to actually account for a negative area and then account for the positive area together. So we'll see that when we're starting with the sine and cosine. Okay, so now let's do the next one as a midpoint. So we're going to do it as a midpoint. And I'm going to change colors on this. Okay. So now we're going to do the same thing, but we're going to do the midpoint. So midpoint, I'm still going to have this right here being my width. So for my areas, it would be my area, it would be 1 times f of, do you remember how to do the midpoint? So, right here. So, if it's a midpoint in between 0 and 1, you can tell me that right there. What is that? 1 minus 0 divided by 2. Or 1 plus 0 divided by 2. Because we're going to have to add to actually get the other ones. We just so happen to get that because it was 0. Why divide by 2? Okay. What is 1 divided by 2? 1/2. Is that the midpoint in between 0 and 1? There we go, right there. So I'm going to do my midpoint for this, which is my formula. I'm going to write it on the first one right here. So it's 1 plus 0 divided by 2. And that's going to give me my 1/2 anyway. Plus my second area, my width is 1 again, times midpoint, so that's going to be f of 2 plus 1 divided by 2. Because isn't 3/2 the same as 1.5? Isn't the 1.5 what I'm looking for right here in between 1 and 2? Yes, that's how I get that value. Okay, plus my next width is 2 times f of, and so my next one's going to be in between 2 and 4, so 4 plus 2 divided by 2. So in between 2 and 4, we know it's 3 anyway, right? So 4 plus 2 is 6, divided by 2 is 3. So I'm showing you the steps to get this for every midpoint here. And my last one for area 4 is 2 times f of, why did I write it like that? F of 6 plus 4 divided by 2. Does that make sense? Having you guys write it over and over like this, and hopefully you'll catch on. You won't have to do it all the time, but for the sake of our notes, that's why I'm actually doing it like this. So this first one, so that's f of 1/2. 1/2 squared is 1/4. 1/4 minus 3 is going to be, is that 11 over 4? Okay, so that's going to be a negative 11 over 4, and then times 1. Especially when we're doing this, fractions are your friends, because you know it's so much easier to do the fractions versus trying to get into some of these crazy decimals. Plus, now the next one is going to be 3 1/2, right? So 3 over 2, which is 1.5. So 3 over 2 squared is going to be 9 over 4. 9 over 4 minus 3 is going to give me, what's that? 3 over 4? So negative 3 over 4. Plus my next part, which is 4 plus 2 is 6. 6 divided by 2 is 3. 3 squared is 9, minus 3 is 6, and 6 times 2, 12. Plus, next one, 6 plus 4 is 10, divided by 2 is 5, and so 5 squared is 25, minus 3 is 22. Yes? 22 times 2? 44. There we go. So we're going to add all those together. Okay, when I put these together right here, that's going to give me what? 13, 14. So negative 14 over 4. Negative what? What'd you get? Negative 3.5? Okay. So by combining those up, we get negative 14 over 4, which is negative 3.5. You agree? Okay. And plus my other side over there, which is going to give me 56. So my answer is going to be 52.5. Yes? Okay. yes. Now, is that so bad? Not really, right? So, yes, it's just not algebra, it's just geometry. Basic geometry with a little bit more steps. And we complicate it by adding in function notation and all this crazy stuff of calculus, which could be boiled down to just finding areas of rectangles. So, we're just gonna get more and more into more rectangles. Now, this right here is going to be my same notation. My exact same notation that I had. So we're going to approximate this integral using bounds. It's a definite integral. And it is from 1 to 9 of the function x minus 3 squared. So my function is going to be this, right? And I am going to partition it according to the x-axis here, from 1 to 9 in 4 subintervals. So 9 minus 1 divided by 4 is 2. And that's why it gives you this right here, length of 2. So that means that's going to be the width for every single one, right? Okay, so there's a left hand, right hand, and a midpoint.
What's the point?
What's the point?
Where is this used?
Oh, where is it used? Oh, it's approximation. So a lot of the stuff that we're doing, I don't care for the approximation very much. I don't, but it's getting into the fundamentals of calculus, of how we build to calculus. You know when we started out doing limits? Yeah, the limit process, which got me to the derivatives, right? Now, using this, the sums of these areas is getting me to the integral process. And it, in all actuality, it comes out to be, it's the area under a curve. When I take the integration of some function, it's the area under that function. Make sense or no? Okay, good. Alright, so let's go ahead and start this in. I'm going to go to another page, so we're going to do left, right, and then midpoint. So left, so it's going to be 1 to 9, x minus 3. Yes. And is 4 subintervals. Alright, so if I'm going to draw a number line for this, which helps me out, 0, 1, 2, 3, 5, 6, 7, 8, 9. And so the width of each one is going to be 2, right? So if this is equal subinterval, so it's my b minus a divided by n is going to give me my width, which is 9 minus 1 divided by 4, which is 2. And again, this is my delta x. That's my delta x right there. Alright, so 2 is my interval. So my first one is going to be from 0 to 2, 2 to 4, 4 to 6, and 6. Oh wait, not. I'm supposed to start at 1. For 1 to 3, 3 to 5, 5 to 7, and 7 to 9. There we go. Alright, so we're going to start with the left hand. So using the left hand, I know that my width for each one of these is gonna be how much? 2. If this is equal width, what can I do with that equal width? What did we do it on the last unit? If they all had the same factor, I factored it out, right? So all of them had a width of 2. So I'm gonna do that. So all of them have a width of 2, so that's gonna make my math a whole lot easier. 2 times, now on a left-hand side, I'm always going to go to the left. So that's gonna be f of what? Uno, very good, plus f of trace, plus f of de Mayo, cinco de Mayo, cinco, plus f of nana, what? Oh, okay. Nani plus ich bin.
No, we don't have 9.
Yep. Why don't we have 9? Tell me, why don't we have 9? Uno, dos, tres, cuatro. How many intervals do I need to have? 4. So there's my 4 areas. And because 9 was at the end, which is on the right-hand side. There we go.
That's because it's the 9.
It's the 9?
Yes.
Because 6 is carried to 7?
7, 8, 9.
7, 8, 9. That's why 9's not there. Alright, 2 times my f of 1, so plug in 1 there. So 1 minus 3 is -2. -2 squared is 4 plus 3, f of 3. 3 minus 3 is 0. 0 squared is 0. Plus f of 5, so 5 minus 3 is 2. 2 squared is 4. Plus 7. 7 minus 3 is 4. 4 squared is 16. So that's going to be 24. 24 times 2 is going to be 48 units. Wow. Is that pretty easy there? Is that making it slightly easier? Okay. All right, I'm going to change up the color again. So, there we go. All right. Now, we're going to do the next one, which was the right-hand side. Right-hand side is going to be 2 times f of, so now in my first interval right here, which one's the right hand? Which one's the right hand here? F of not 1, 3, because it's either the left side or the right side of the rectangle. So we're doing right side now. So that means that it's going to be f of 3 plus f of 5 plus f of 7 plus f of 9. There we go. And we are including 9 on this one because we have 4 intervals, right? 4 intervals. So here's A1, A2, A3, and A4. And for each one of these boxes, we're picking the right-hand side of that box. All right, so let's see. F of 3. 3 squared, or 3 minus 3 is 0. 0 squared, 0. 5 is going to give me 2 squared, 4. 7 is going to give me 4, 16. F of 9 36 squared, 36. And let me see, what are we gonna get there? I'm gonna get 20, 56, 56. And my last way of doing it was starts at M, ends in point. What's wrong, Christian?
And boom.
I did, didn't I?
You did 20 plus 36, which was 56, but equals 56, but you didn't or 4 counts plus.
Oh, you're right. Haha, see? So 20, 36 is 56 times 2. 112. Dang. Why'd you help me on that one? I just made a mistake for all of you too kind to grill me in the commentary now. Okay, good. Anyway, alright, next one's gonna be midpoint, right? Last one's gonna be midpoint here. And, let's see. So, since you guys were paying attention earlier, 2 times, now, do we have to actually go through and write out the function as 3 plus 1 divided by 2? No, we could do it here. So in this one, especially since it's equal parts, it's easier to do it like this. So this is going to be f of 2. So f of 2 plus f of plus f of plus f of So it's the ones right in the middle. So 2, 4, 6, 8. All right, so let's do the math. 2 times f of 2 is going to be 1 plus f of 4 is also 1 plus f of 6 is going to be 9. F of 8 is going to be 25. Yeah. Yeah, 25. So what's that going to be? 36. 36 times 2 is 72.
Which is the correct approximation?
What's the what?
What's the correct approximation?
They're all correct. Because it just depends on which one you're using. Those are approximations, but an exact answer, I'll show you how to get an exact answer here. just so you know. So we did the integration, now we plug in, so it's gonna be 9 to the third over 3 minus 3 times 9 squared plus 9 times 9 minus the lower bound, which is this one. What's that? 9 to the third is, it's 281,721? No? 9 to the third power.
9 third, 2 third,
Hmm? 243? Okay, so 243, and so 243 divided by 3 is gonna give me 81. 81 times 3 is gonna be 243? No, yeah. Plus 81 minus my lower bound of 1/3 minus 3 plus 9.
Whoa, whoa, wow. Wait. 9 times 9 is 81. 9 times 81 is 729. 9 times 81 is 729.
Okay. Are you talking about this one here?
That's funny.
Huh? The front one?
It's just 243.
Oh, so this one is 243, not 81? Oh, okay, thank you. See, my mental math is not very good. Like that? Yeah? Okay. So it should be, let's see, 81 minus the, what's that gonna be? 6, 5 2/3, 15, 17 over 3, 5 2/3, so that's gonna be 75 and 1/3? Something like that. 75.3, repeat. So, in your handy dandy calculator, because I use this to check my work. This works for definite integrals, so it makes your life easier. So if you have a problem that you don't, not sure if you have the right answer, 74 and 2/3, dang it, forgot to carry the 1. So, anyway, so that's how we're eventually gonna end up doing those. Mental math. You're not ready? So, yeah. Alright, so we're gonna pick this up again on Wednesday next week.
Wednesday.
I don't see you Monday or Tuesday.
Why not Tuesday?
Oh, are we gonna have a practice?
I'm gonna see you Tuesday. What?
Are we gonna have a practice safety test on Tuesday?
No, because I have to give the test again.
Wait, what's Tuesday?
Oh.
Huh?
What's Tuesday?
Tuesday is the AZ Science,
Oh, never mind. I didn't see.
and you're gonna be here anyway.
When's gonna be our CTE test?
The CTE test?
Yeah. Like the, well, like just CTA.
When are the CTE teachers gonna give out their CTE tests?
April 8th. Okay. I'm like, wait a minute, you're not in my CTA class. Alright. Anyway, like, share, and subscribe.